Okay, I hope the internet will hear me too. Again, welcome. And well, today I'm going to speak about serverless on top of the Kubernetes. So this title is it can be pretty much confusing if you're thinking that we're talking about running Kubernetes as serverless. No, we're not doing that. I'm not sure if that would be stupid or not. Maybe it's genius. However, I'm Teemu, and I come from a company called Emblica. It's hard to pronounce in Finnish and English. It's also hard to write. I have seen lots of different variations about it. Like sometimes it's B, sometimes P, or C or K, whatever. However, we're super small. We're just five people, and we're consulting about data engineering, DevOps, and sometimes a little bit machine learning stuff. And well, we have mostly our customers are like startups. There is some mid-sized companies, but also enterprises like Sanoma or Ottawa Media, or let's call CGI. And well, currently we are working with Kubernetes and Docker and Ansible and that kind of stuff. I'm going to start this with a lesson about history of DevOps. And this one is a little bit opinionated version. Have you seen this one? Yeah, you should. This was the idea of DevOps, that there is just one team that can deliver the application from their own laptops to servers running in the cloud. And it was a pretty nice idea, but this was the implementation. So they are going to hire some specialists called DevOps guys, and and then they are responsible for full deployment. They are doing everything. They're doing infrastructure, they are connecting cables, they are configuring Jenkins, and well, yeah, it's cool. Like those Supermans, everybody loves them, and probably that's the reason why they are so expensive guys to hire and hard to hire too. So there must be a guy who knows the infrastructure and also knows some software development. Pretty hard, I could say. I'm going to introduce you a new ideology today. It's called, DevOps. But let's color it green, so it's different DevOps. Well, it will be actually pretty much the same, but this one is added. So operations team, there is still ops. They have to maintain the platform where the DevOps, or actually the whole team, can deploy on. And now when we are here in Kubernetes meetup, I could probably say that the platform will be the Kubernetes. So in future, there will be the ops team doing the infrastructure and maintaining the platform, Kubernetes, and then the whole team can deploy on it. And it works then. I believe so. Or then we have just more of these guys and, well, no, these guys, and then everything's fine. It's like previously. However, we are talking about serverless today. And what I mean, I probably have to define it. Because mostly serverless is using servers, if some doesn't know. And well, if we want to define it a little bit better, probably should think about what does the serverless offer you. And well, it removes things. It removes need for these guys. Provisioning, operations, scaling, no more availability problems. That's all what serverless does. But actually, when I was thinking about this, it's the similar that Lucas here promised that Kubernetes does. And well, so there is not so much difference then. Well, do you remember this? It's PHP. It's beautiful. It's microservice. It tells you your IP address. Really, it's microservice. And well, you know how these kind of microservices were deployed? AirSync, SSH, Vim, anybody? Yeah, it's the way how you deploy this kind of microservices. But well, now when we have the Kubernetes stuff, things get simpler. We have to just build an image, push it to the registry, make some manifests, and push them to Kubernetes. And then it's just like that. Well, maybe we still have a need for deploying software more easy. And well, this is what the serverless might be for Kubernetes. It's more agile. And then there is another thing that kind of the PHP microservice serverless platform did. It's running, not all the time, but when the user issues a request or some other event or action to start the service, and then it does something and it shuts down. And that's the point. It's like on demand. Well, currently when we are creating some Node.js services, they're running all the time and they're consuming resources, memory and, well, some other space. And then we probably have a problem with that in some point if we have lots of those microservices doing important stuff, like telling the IP address. So probably it's not game changer, but we still can have some point with that. Well, then we can think about why we use Kubernetes on top of serverless. We used to have the PHP stuff going on. Well, first of all, the operations team that I just told that they are going to maintain the Kubernetes, they don't want to maintain any other system anymore. Trust me. Well, then Kubernetes actually offers pretty good environment for keeping stuff around the serverless stuff and other containers that are going on, like databases, and it has some scheduling system that if somebody will break your server, it's going to redeploy it somewhere else. And it has some other cool services too. There is some networking, and probably people will develop more stuff on top of the Kubernetes. So I think it's something that we can rely on in the future, that somebody is going to maintain Kubernetes, somebody is going to develop it further.
That's what they said about PHP.
Yeah, well, that's true, but I think there is now, tell somebody, what's the current version of PHP? Somebody knows?
7 something.
Okay, so they did. So let's go into serverless on top of the Kubernetes. Currently, I could Google these guys, their logos, and they're also projects on top of the Kubernetes, except the OpenWhisk, which is more like general serverless platform. It's originally created by IBM, so it must be very good. And well, I haven't used it or tried it yet, but I think it has lots of stuff in it. And well, then there is the other projects. They are a little bit smaller. The Kubernetes is probably good. I've tried it once, worked well. Function, never tried, and Fission, we're going to demo about that. So let's start demo time, or maybe demo effect time. So let's see what happens. Let's first start with the text editor. This one is the today's version of PHP microservice. It's made with Node.js. It's the language from the future. And it will send out, for the response, it will send hello Kubernetes. I'm not going through the installation of Fission, but you can read it from the interwebs. And after that, you have some pods, as you can see here. So it will create lots of stuff running on your Kubernetes, and it will orchestrate everything. And now I'm going to show first how I'm using it as a user. And then after that, I'm going through like what happens behind the scenes. So here is my function or my microservice or my serverless lambda function or something, whatever you want to call it. And here is my cheat sheet. First, let's create environment. So with this Fission project, you have to have some environment for running those. So if you're using Node.js, you probably want to have Node.js environment, or if you want to have PHP, then you need PHP environment and so on. So we're using the Node.js environment from the Fission project, and I will later show you how it's created, and you will be, it's horrific. Well, let's create it first. Wait a minute. Here, more space. So, here we go, and we create it. Ta-da! What happens now is that the Fission will download something from the Docker registry and pull something running. But still, if we go into this URL, not this one, this here, nothing found, and here, nothing found yet. Okay, 404, page not found. Let's deploy the hello.js, which look like this. Again, we are going to copy paste some cheat sheet stuff. And here what happens is that we create function called hello. It uses environment Node.js. It's uploading hello.js, and it binds it to URL hello with HTTP method get. Let's try it out. It worked. And now, let's hope. Hello, Kubernetes. Okay. Well, clearly we have here spelling mistake, so we need to fix it. Let's open it again and fix it. And then probably we would like to have some counter. You see how good I'm coding. So let's make global variable. It's always good with serverless stuff. And let's start it, or let's update it. And again, I'm going to just copy paste it so I don't have to write it. So here we have another command, Fission fn function update. We are referring to the old function name, and we are just uploading the same file again. Let's see what happens. Well, it's already there. I didn't have to build some containers. And if you actually go into that address, you should be able to send me more numbers. Okay. This works fine, but what if we have a little bit more complicated software? Let's make API that provides us user-submitted questions. And here we have it created with Python. We have 3 files. So let's see. This one is, first the API. This one connects to Redis database. And actually, I created already the Redis database with this old and fancy Kubernetes manifest that takes like 100 lines. And after that, I can refer it inside of the Kubernetes cluster. As Lucas showed you, the networking stuff then manages out how to connect there. And from here, from the actual code, we can just refer it as hostname.redis.questions. Let's see if this works. I think there is already something in the Redis. I hope it's not something I don't want to show in the publicly, but Let's try it out. So first, once again, we are using Python environment because now we're deploying Python. Here we go. Then we are creating first function. Let's say we want to have the questions API here. Okay, and now let's see. This was page and found. Now we have fancy API. Okay, well, not so bad as I thought. So here we have some stuff going from the Redis database, but we still can't have any way to add more things. So let's create more functions. It's always good. We had the add question function that I can show it for you. This one is just taking from the body, from the request body, some stuff and push it to Redis. Okay, let's try it out. Okay, we can't test this yet. Well, we could, but we don't want because we want to create some fancy user interface for that. So we have this function that creates a form. So let's copy paste more stuff. It's the first one. And here we go. Send questions and let's see. Yeah, there it is. And now we can send some stuff. And I think now it's supposed to be here. But once again, we have problems with our code. We have here some nasty white spaces. Let's see it from the form. Oh yeah, can't do any HTML. Okay, we update it. I want to update with this. And now I think if we send some more stuff. Hello. We can probably find it from here. Okay, there it is. That's how the fission and the serverless stuff works. Like, that's how you deploy software, like in the old days. Except probably the Redis manifest, but you didn't have Redis in the old days, so it doesn't matter. Well, let's get back to where we were. I'm curious if it works. Well, probably it works in the internet still. So how it works, and now we're talking about the fission. There is a pod or there is a service called Pool Manager, and the Pool Manager will create generic environment pods. It will make a little pool of those. So the generic environment pod actually consists very, very simple servers made with those languages, made with those environments. At least with Node.js and, for example, Python. Then, when we are issuing a new command, some event, for example, HTTP request to router, the router will ask from storage layer or from the managing layer that please specialize me some pod. And so the API specializes one pod from the generic pod pool, and it injects the code inside of the pool, and after that it can answer for the requests. The router can be it can spam on HTTP request, but it can also spam probably some timer events or like scheduled events, or it can read some stream, or it can ask some jobs from some queue. There is lots of options even with this one. And what happens in the code level? This one is from the Python environment. So first, when the request comes or new function comes in, it will happen the specialized step, and it will actually just call one endpoint, HTTP endpoint, and specialize it. And here you can see that actually it posts some data, and then the actual implementation which holds the serverless function will inject inside of one variable and will define it. And then when the request comes, there will be the app root, which actually evaluates the user function. So it works like this. It's not magic, but I think it's pretty ugly way of doing this. They are going in the future. With Fission project, they are going to change this a little bit. For example, the current environment implementation, it's not very good for compiled stuff. So if you are writing something with Go, then there isn't any build pipelines or something like that, and it might be hard to get into the container. But well, there is already Go runtime. It's just not very beautiful. With Fission, you will get very fast cold start, and you don't need to hustle with the image management. But then there is lots of problems still. For example, one file is currently only supported option. You can't just push some folder like with some cloud providers, like Amazon Lambda. You can send the whole zip package, and you can't add your custom dependencies. If you want to have some custom dependencies that are not already in the environment, you have to build your own environment. And well, I think that a little bit like it's it's not something you want. Then one thing that people would likely to have is some on-demand running on normal containers, normal images. You want to have your own container without this weird specializing stuff going on. You probably would like to have it to run only when there is something happening on demand. And well, currently this can't do that. If it can in the future, I will write that one. So then some new project that you can find from .io domain will do that. So take care. Okay, thank you, and thanks for listening. I hope you enjoyed, and if you have any questions, please ask. Any questions?
Are these slides going to be available as well?
Yeah, and actually the whole stream will be also available from the YouTube. So, but yeah, I think I will make these slides available too. Other questions? Yeah.
If you do something stupid on your function, can you break the whole runtime that's running other functions as well?
Well, the short answer is yes. Longer answer is no, because pretty quickly the runtime will fix itself because it's going to restart. But yeah, currently there is a problem that if your code contains, let's say, a syntax error, and it injects it in, and then it can't evaluate it, it will just shut down and it will tell you infernal server error, and that's all. Yeah. So in the future, they are planning with the Fission project that they are going to support some checks before running. Like with compiled languages, if it compiles, it works. But with with the other languages, you can probably try to sandbox or something like that.
So that will affect for the fast start?
Well, yes and no. It's going to be, the check's going to be before it's deployed. So in the deployment step, when you're actually pushing the code, it will do those checks, and after that, when it's running, it will just start. Yeah, so it will work normally. Yeah.
Have you used this in any real cases, like with customers?
No, not currently. We don't have any of those in production. We're just testing it out. I think it's not yet production ready for various reasons. Yeah. But
follow-up question: is there like nice tools for continuous like integrations, or like deploying the only functions? Let's say I have a repo with multiple functions and so on.
Not yet. Not yet. The tooling consists now currently only the Fission tool. It has some, but mostly those are for managing the managing the stuff. So you can delete or list or something like that. But for deployments, it's pretty lightweight. So only one at a time. Of course, you can use the bash and do stuff like in the old days. Yeah.
Okay.
Okay. Well, if not anything else, I think we will have a short break, and after that.
We can actually ask you guys, do you want to have a short break and grab a drink, or are you good to continue?
Nodding means yes.
How many wants to continue straight away? Raise your hand. Okay,
Let's have a break. Okay.
couple of minutes and
Couple of
grab a
minutes.
new drink and
Yep.
whatnot.